Now, the next model of differential equations is linear equations. I mean to say linear differential equations. There has been a particular model, rather particular format to notice or to recognize that a given equation is a linear. Let us now observe its standard form. Any equation of the form dy by dx plus py is equal to q, where p and q are functions of x is called a linear differential equation. Differential equation, and it is of course linear in y, we say linear in y. There has been a fixed format. Yes, you must be able to look at the given equation in this form only, then only you can say that it is linear in y. Why? Because y is observed here of first degree. Here no y's will be present. In P no y's will be present. It has been decided that P and Q are functions of x only. And we are able to see y at only one place. This is y with first degree. With that reason, we say that this equation is a linear differential equation, linear in y. You may get it out. Now you may get it out. Is it possible to observe a given differential equation linear in x? Why not? That will also be there. What is it? dx by dy plus px is equal to q can then be called an equation, linear differential equation, which is linear in x, of course. In such a case, x appears at this place. P and Q will then be functions of y, linear in x, and this is linear in y. Let us first know the methodology of solving an equation and a linear differential equation which is linear in y in the beginning. After practicing it well, we shall then turn our head towards the method of solving a linear differential equation which is linear in x. So let us first focus our attention on the method of solving a linear differential equation which is linear in y. Just now, previously, we have noticed that without going to the previous bulkier methods, homogeneous, non-homogeneous, etc., the way of using exact format, the exact model, or the models of an exact equation are quite simpler, rather than using y is equal to vx or any other thing. Homogeneous, non-homogeneous methods are there. Without using them, it is advisable to use the format given in exact equations. Okay, by converting this in terms of mdx plus ndy is equal to 0, a particular integrating factor is designed for this, is designed for that. Okay, all those things appear, they come out if you can know the complete method of solving this differential equation. Now, the next heading is solution of a linear differential equation. How to solve it? Let us now know it. Method of solving a given linear differential equation which is linear in y. What I mean to say is that by that heading, by means of that heading, what is our actual purpose? Our actual purpose is to know the method of solving a differential equation, linear differential equation which is linear in y. Okay, let the given dE, by dE I would like to mean the differential equation, be dy by dx plus py is equal to q, where p and q are functions of x. That is functions of x only. No question of getting any y in p and q. Yes. Step 1, that is a given equation. Step 1. What is the first step that you have to put? Step 1. Integrating factor is equal to, I think you could have recollected the meaning of integrating factor. That is that factor or a function or an expression, of course, which makes the given equation exact. Yes, is equal to e power integral p dx. E power integral p dx. How? What is the reason behind that? There is a little proof, very simple proof is there to estimate that IF. We shall look at within 1 or 2 minutes. Let us now completely know the method of solving. This is step 1. And step 2. You may be guessing step 3, step 4, step 5, such things may be there. There are no such things. This is the last step, of course. In this step, we are going to have directly the solution. Yes, solution is y into integrating factor is equal to integral of q into integrating factor dx. This is the first thing that you may have to learn, and ultimately the solution is this: y into integrating factor is equal to integral of q into I of dx. In this session, we shall go through the main concepts of linear equations, some more examples regarding linear equations, and the salient features, specialities in that particular heading. We recall that a differential equation of the form dy by dx plus py is equal to q is said to be a linear differential equation, linear in y, if p and q are functions of x only. You must be able to see only x's in p and q. In such a case, we say that this is linear in y, and for this equation, the integrating factor needed is e power integral p dx. I believe that you know what is meant by an integrating factor. We could have already discussed with that. That factor or function or expression with which we multiply a non-exact equation to make it exact is called a linear factor or an integrating factor. There is e power integral p dx for this one, and of course the solution is then given by y into integrating factor is equal to integral of q into integrating factor dx. These are the salient features of linear equations. This gives the method of solving. In this method of solving, we have only 2 steps. In the step 1, we get the integrating factor, and in the step 2, that is the last step, we write the solution directly as y into integrating factor is equal to integral of q into integrating factor dx. Now, of special interest is the case how this integrating factor has been designed. Should you believe it, or is there any sufficient reason for that? There has been a beautiful reason. A proof is also there. Of course, a very simple proof. Let us now follow that proof so that we can remember this integrating factor very well for a long time. So, we shall now take interest in finding the reason why this integrating factor is chosen to solve this equation. Well, the given differential equation is dy by dx plus py is equal to q. Okay, we want to solve this by direct integration. That is, we want to get it converted into an exact equation, and in that business we need an integrating factor. Let me assume that integrating factor as some v. Then what happens? V into dy by dx plus v into py is equal to v into q. Call this equation 1. You see, our actual purpose is to look at this LHS as d by dx of something. In that something, y definitely takes a part because dy by dx is appearing here. So y into v is identically equal to v into dy by dx plus v into py. Let me assume like that. Come on, simplify this LHS. Dy by dx into v plus y into dv by dx is equal to v into dy by dx plus v into py. So that you can cancel this v into dy by dx. Now you have y into dv by dx is equal to v into py at your disposal, and in this remainder you can cancel y also. Therefore you have dv by dx is equal to v into p. V into p. Good. Therefore dv by v is equal to p dx. On integrating this, we have log mod v is equal to integral p dx, of course to the base e. And from this you have directly v is equal to e power integral p dx. This is the reason why we choose this particular factor as integrating factor. This particular factor as integrating factor. This is the reason. Okay. So, when you look at a given equation in the standard form dy by dx plus py is equal to q, then and there itself you believe or you declare that that is linear in y, and the integrating factor, the necessary integrating factor there which helps us to look at the given equation as exact is v is equal to e power integral p dx, and the solution is y into, you see, the solution is of course directly obtained from this. D by dx of y into v is equal to v into q. What is v? It is just nothing but the integrating factor. Well, let us now write this concept very clearly. Given differential equation is dy by dx plus py is equal to q. Multiply the entire equation with e power integral p dx. Observe carefully. This part is just nothing but d by dx of y into, let me call this if, is equal to q into if. What is if? This part I'm supposing to be if. You differentiate this, dy by dx into if plus y into derivative of this. Derivative of e power integral p dx is e power integral p dx into derivative of this is p into y. From this, we directly have y into if is equal to integral of q into if dx, which is the prescribed solution. Which is the prescribed solution in the case of those equations which are observed in a linear form, linear in y. Linear in y. These are the steps. I think you could have followed. Of course, absolutely in the similar fashion, we can observe those differential equations which are linear in x also. How can they look? Let us see. A differential equation of the form dx by dy plus px is equal to q, where p and q are functions of y only, is called a differential equation, a linear differential equation which is linear in x. Okay, then how to trace it, how to identify it? X appears at only one position. Here in p and q, we may not be in a position to see x at all. X lies with first degree. That is why it is said to be linear in x. And for this position, the integrating factor is given to be, integrating factor is equal to e power integral p dy. And accordingly, the solution is x into integrating factor is equal to integral part of q into integrating factor dy. This is the solution for that equation which is linear in x, Yes. And the process of obtaining this solution is also exactly similar to that in the process of obtaining the solution for dy by dx plus py is equal to q. Absolutely similar. That is why I'm not going to the details of that part. You can easily obtain and you can believe that this is the solution. X into integrating factor is equal to integral of q into integral factor dy. Well, now we shall turn our head towards solving some problems, viewing some examples regarding those linear equations. This is the problem which was given in some JEE question paper. Look here. First of all, you observe throughout this equation there is one and only one y. Yes. Well, this can be written as dy by dx plus minus x by 1 plus x into y is equal to 1 by 1 plus x. I think you could have understood what has been done by me. I have divided the entire equation with 1 plus x, so that this looks like dy by dx plus py is equal to q, where this part is for p and this part is for q. Isn't it? Therefore, p is equal to minus x by 1 plus x and q is equal to 1 by 1 plus x. Therefore, we declare that this equation is linear in y. Call this equation 1. Therefore, what is the immediate step that you may have to perform? You are supposed to have the integrating factor first. What is the integrating factor for this equation? Is equal to e power integral p dx. Isn't it? This is equal to e power integral minus x by 1 plus x dx. This is equal to e power integral 1 minus of 1 plus x by 1 plus x dx. You please observe the things that are happening. I could have written this minus x as 1 minus of 1 plus x. What happens then? This is e power 1 by 1 plus x, 1 by 1 plus x minus 1 plus x by 1 plus x is 1 dx. Isn't it? Therefore, it is e power log 1 plus x minus x. Isn't it? This is equal to e power log 1 plus x by e power x. Therefore, this is 1 plus x by e power x. 1 plus x by e power x. That is the integrating factor we could have obtained. Well, the first step is successfully completed. What is the first step actually? To get the integrating factor. What is the integrating factor? E power integral p dx, that is e power minus x by 1 plus x, and by usual transpositions you can have this integral. This could have been discussed already while studying definite indefinite integration, isn't it? Okay, that is what we call the integrating factor. What is the next step? That is the final step of producing the answer directly. We shall now proceed to do that. You please understand, you please notice those steps. Well, after finding the integrating factor, let us recollect the style of producing the answer, that is the solution. What is the solution? The solution is tell me the formula, rather procedure, rather rule. Y into integrating factor is equal to integral of q into integrating factor dx. That is y into 1 plus x by e power x is equal to q. What is q? You please remember. Yes, it is of course 1 by 1 plus x. 1 by 1 plus x into 1 plus x by e power x dx. Automatically 1 plus x will be cancelled, leaving you 1 by e power x, that is e power minus x, and its integral is e power minus x by minus 1 plus c. Therefore, y into 1 plus x by e power x, you see this is minus e power minus x, that is minus 1 by e power x, bring it this side, plus 1 by e power x is equal to c. Well, we are to find c also. Not only that, our main question is what is y at 1 that we have to find. Good. Multiply throughout by e power x, y into 1 plus x plus 1 is equal to c e power x. But y at 0 is minus 1. That is, if you take x is equal to 0, then y will be minus 1. What happens? Implies minus 1 into 1 plus 0 plus 1 is equal to c into e power 0. Minus 1 into 1, minus 1. Minus 1 plus 1, 0. Therefore, c is equal to 0. Therefore, c is equal to 0. Hence, the solution is y into x plus 1 is equal to 0. I have taken c as 0 because we could have obtained c like that by using the information y at 0 is minus 1. Well done, we could have got the actual solution now. What is the main question? Y at 1. If x is equal to 1, then y into 1 plus 1 is 0. Therefore, y is equal to minus 1 by 2. Implies y at 1 is minus 1 by 2. Y at 1 is minus 1 by 2. That is the question. The next question is before us. Please read out the question carefully. 1 plus y square plus x minus e power tan inverse y into dy by dx is equal to 0. Come on, friends. You observe the nature of the equation. Y is not linear here. It is existing with an exponent 2. You see, y square is able to be seen. Thereby, we say that we see that it is not linear in y. At the same time, x is present just at one place and with first degree. Therefore, here itself, by simply looking at the question itself, you can trace that this is not going to be linear in y, but it can be linear in x. That is, we must try to get it converted into the standard form of those equations which are linear in x. I think you could have recollected that dx by dy plus px is equal to q, isn't it? Let us try. This implies x minus e power tan inverse y into dy by dx is therefore equal to minus of 1 plus y square. I have sent this 1 plus y square to that side. Thereby, you can easily look at dy by dx is equal to 1 plus y square by e power tan inverse y minus x. I think you can understand this. I have sent this here, and I could have made use of this minus symbol to just revert this. This is dy by dx. We don't want it. Why do we not want it? What is the reason? In the beginning itself, we are not able to see y with first degree. Therefore, this is not going to be linear in y, and this must be converted into that form which is linear in x. Come on, you find dx by dy from this equation. Dx by dy is equal to e power tan inverse y minus x by 1 plus y square. Again, you have two things on the right hand side. Whenever one thing is e power tan inverse y by 1 plus y square, and the other is minus x by 1 plus y square. Now, I would like to pull that minus x by 1 plus y square to this side. What does remain? Dx by dy plus 1 by 1 plus y square into x is equal to e power tan inverse y by 1 plus y square. I think you can understand. Well, my dear, this is absolutely in the standard format of those linear equations which are linear in x. That is dx by dy plus px is equal to q. Isn't it? Since in the place of p of the standard form we have 1 by 1 plus y square, and in the place of q of the standard form we have e power tan inverse y upon 1 plus y square. This is p and this is q of the standard form. Well, we shall now we shall start to have the procedure, follow the procedure. The first step is, come on friend, what is the first step? You are supposed to have the integrating factor. What is that integrating factor? Integrating factor is equal to e power integral p dy, as it is linear in x. You please remember the difference. If the given equation is linear in y, if would be e power integral p dx. But here in this problem, it is linear in x. Therefore, integrating factor must be e power integral p dy is equal to e power integral. What is p? 1 by 1 plus y square dy. 1 by 1 plus y square. What is the integral of 1 by 1 plus y square? E power tan inverse y. This is IF. This is IF. Successful. The first step is successful, and the thing that remains is the second step or the final step of writing the solution. The solution is come on friend, recollect the solution. What is the solution? X into IF is equal to Q into integral of IF. Integral of Q into IF. Come on. X into IF is e power tan inverse y is equal to integral of Q. What is Q? E power tan inverse y. E power tan inverse y by 1 plus y square into e power tan inverse y dy. This is equal to t dt, where t is equal to e power tan inverse y. E power tan inverse y. This is t. Automatically this is dt, isn't it? That is dt is equal to e power tan inverse y by 1 plus y square dy. What is integral of t? T square by 2 plus c, that is e power tan inverse y whole square, that is e power 2 tan inverse by 2 plus c. That gives you the final solution. So the main and important thing here to observe is you have to notice the nature of y in the given equation. It is not in the linear form. Y square we are able to see. So y is not with first degree. At the same time x is with first degree, isn't it? Therefore, we are supposed to get it converted into that standard form of those equations which are linear in x. That is dx by dy. We have to get it. Keeping that point in our mind, only we could have arrived at this step. By looking at that equation simply, we have noticed P and Q and IF, etc., etc., etc. That is the solution. Please follow this. Another standard question is before us on the board. Let us understand the question. X dy by dx plus 2y is equal to log x, that is log x to the base e. Then e square into y at e minus y at 1 is equal to how much? Well, my dear friend, here you may be getting a doubt. Both x and y are able to be seen in first degree with the exponent 1. But you see, x is seen at 2 places, but y at 1 places. At that position, we give preference to that variable which occurs at 1 place only. Okay, so we are confined to the plan that this is supposed to be obtained into the form linear in y. Okay, divide throughout the equation with x. What happens? Dy by dx plus 2 by x into y is equal to log x by x to the base e. Fantastic. This is absolutely in the linear form. This we have for P and this we have for Q. Let us not waste time. Let us apply the first step. What is the first step? IF is equal to e power integral P dx is equal to e power integral P. What is P? 2 by x. 2 into 1 by x dx is equal to e power 2 log x. 2 log x is nothing but e power log x square, which is of course x square. Well, nice, we have got IF. What is the second step? To get the solution. What is the solution? Therefore, the solution is, come on, y into integrating factor, that is y into x square, is equal to q into, what is q? log x to the base e by x into x square. 1x will automatically be cancelled, leaving you integral of x log x dx. This is nothing but x square by 2 log x minus x square by 4 plus c. How? You can use directly integration by parts, that is one way, and the other way is there has been a standard integral x power n log x dx is equal to x power n plus 1 by n plus 1 into log x minus x power n plus 1 by n plus 1 whole square plus c. I could have made use of this standard result from the knowledge of indefinite integrals. We could have derived that, of course, by using integration by parts. So this is the answer. Therefore, y into x square is equal to x square by 2 log x minus x square by 4 plus c. Good. This is the solution. But this we do not want. What do you want then? That e square into y at e minus y at 1. From this, if x is equal to e, what happens? If x is equal to 1, what happens? We are supposed to have x is equal to e, suppose you put, then y into e square is equal to e square by 2, what is log a? 1, minus e square by 4 plus c. From this, y is equal to 1 by 2 minus 1 by 4 plus c by e square. 1 by 2 minus 1 by 4 is 1 by 4, isn't it? So, this is equal to 1 by 4 plus c by e square. Therefore, y at e is equal to 1 by 4 plus c by e square. One particular value has been obtained. Still there is one more thing to be obtained. What is that? Y at 1. That is what happens when x is equal to 1. Substitute here. Y is equal to y into 1. Log 1 is 0. 0 into 1 is 0 minus 1 by 4 plus c. Plus c. Okay. Y at 1 is equal to minus 1 by 4 plus c. Well, my dear, you try to make use of these two things to calculate this. Therefore, e square into y at e minus y at 1 is equal to, this is y at e, e square into that, come on, e square by 4 plus c. What is y at 1? Minus 1 by 4 plus c. C and c will go away. So that the answer is e square by 4 plus 1 by 4. What are you going to get? E square plus 1 by 4 is the right answer. E square plus 1 by 4 is the right answer. Beautiful question. One of the standard questions. Observe the next question. dy by dx plus y cos x is equal to half into sin 2x. And y at 0 is 1. Using this one, find y at pi by 2. Okay, we are very lucky. Why? Because the given equation itself directly is linear in y. And in the place of p, we have, what is p? Cos x. What is q? Half sin 2x. Isn't it? Okay, look here. Is clearly linear in y. So, we can directly make an attack of finding if is equal to e power integral p dx. E power integral cos x. What is e integral sin x? Therefore, what is if? E power sin x. E power sin x. We should feel happy because it has been obtained very simply. Okay, right. Okay. Therefore, the solution is the solution is y into e power sin x is equal to q into, what is q? Half into sin 2x, half into 2 sin x cos x into e power sin x dx. E power sin x dx. You can cancel this too. This is nothing but sin x into e power sin x into cos x dx. Am I right? So that this is t into e power t dt, where t is equal to sin x. T is equal to sin x. Or dt is equal to cos x dx. And from the knowledge of indefinite integration, we know that this integral is e power t into t minus 1 plus c. Therefore, the solution is y into e power sin x is equal to e power sin x into sin x minus 1 plus c. Here, we should have c. What is c? We must find. To find c, we must make use of the information y at 0 is 1. But y at 0 is 1. Substitute here. Therefore, 1 into e power sin 0 is equal to e power sin 0 into sin 0 minus 1 plus c. You see, e power 0 is 1. Hence, 1 is equal to minus 1 plus c, or this is 1. This is minus 1. 1 into minus 1, minus 1. C is equal to 2. C is equal to 2. Okay. Now, we shall attend to the main question. What is the main question? Y at pi by 2. What happens when x is pi by 2? Also, x is equal to pi by 2 implies, come on, substitute pi by 2 in the place of x, y into e power sin pi by 2, that is 1, is equal to e power sin pi by 2 into sin pi by 2 minus 1 plus c. Therefore, y into e is equal to 1 minus 1 is 0, 0 into e is 0 plus c is 2. Therefore, y is equal to 2 by e. By making use of y at 0 is equal to 1, we are able to have the value of c as 2. But the actual question is y at pi by 2. We have to find. So what happens when x is equal to pi by 2? You substitute x is equal to pi by 2 here. Y into e power sin pi by 2, that is y is to e power 1 is equal to e power 1 into 1 minus 1 plus c. Thereby we have ye is equal to 2, or y is equal to 2 by e is the right solution.